In this lesson, we're going to be learning what prime numbers are. The main thing we need to know for this is how to find factors of a number, so let's quickly review it. Remember, factors are values that multiply to get the number, so if we're after the factors of 18, 1 and 18, always the first two are 1 and the number itself, and then we're going to try 2. Does 2 go into 18? It does, because 18 is even, and it's also on my times tables. 2 times 9 is 18. Does 3 go into 18? Yes, 3 times 6 is on my times tables to get 18, and so 3 and 6 are factors as well. And now we try 4. Does 4 go into 18? I'll look at the times tables. No, it's not there. And I don't actually need to try 5 because 5 is more than halfway between 3 and 6. But if I did try 5, I'd find out that it's not on my times tables. 18 is not on my 5 times tables. So there's all the factors of 18, 6 of them. A prime number is a number that has only two factors, itself and 1. So 7 is a prime number because these are 7's factors, 1 and 7, and no other number goes into 7 without remainder, so it's a prime number. Now if it's got more than two factors, it's called a composite number, and 8 is a composite number because 1 times 8 gets you 8, but so does 2 times 4. Composite just means really more than one put together, and so when we're looking at composite numbers, it means there's more than one way to get it by multiplying, and so 1 times 8 works, but so does 2 times 4, so it's a composite number. The number 1 has only got one factor, and that's it, 1, and so it's actually not a prime because a prime's got to have two factors, and so it's not prime, and it doesn't have more than two factors, so it's not composite. So that's important to remember. 1 is usually not considered a prime number or a composite. Now there's some debate in the mathematics world, but the consensus tends to be that 1's not going to be a prime number. Okay, let's look at some examples now, and we're going to state whether these numbers are prime or composite. So we're going to start with 11, and we've just got to decide, does anything go into 11 except for 11 and 1? And it doesn't. I've looked at all my times tables, there's no other way to get to 11, and so I write down 11, I say it's prime, and I give the reason. Only 1 times 11 works. So that's our answer to that question. If I looked in the back of the book, it would probably just say prime or composite, but we want to show why as well. Only 1 times 11 works. What about 15? Does anything get you 15? It does. 3 times 5 gets 15, so that means 15 is a composite because 3 times 5. Now, if there are a couple of different options, you could pick whatever you want. You could write down 5 times 3 there, or if there are more ways to get 15, doesn't matter what you write down, just write down any one of them that is not 1 and 15, just to show that there are other options. For 21, it's a composite because 3 times 7 equals 21, and for 23, there's nothing else. It's just 1 times 23, so we write down that 23 is prime because only 1 times 23 works. Now in the next one, we've got to find prime numbers that are factors of 18, and so we'll have to start by listing the factors of 18, just using our usual method that was outlined in the you need to know section. And then once I've got those factors of 18, I have to work out which one's a prime. 1 is not a prime number because it's only got one factor, and prime numbers need 2, so we don't put anything around 1. 18's not prime because 2 times 9 gets 18. 2 is prime because there's only 1 times 2, that's the only way to get it. 9 is not prime because 3 times 3 gets 9. 3 is prime because 1 times 3 is the only way to get 3. And 6, we've got 2 times 3, so that's not prime. So there we go, I've found the only two prime numbers that are factors of 18, so I can just write them down, 2 and 3. Now, once you've done enough questions, you'll get used to the first several prime numbers because they don't change, obviously, so you'll just know these numbers are prime numbers, and you won't have to work them out anymore. These numbers aren't prime numbers, so you'll get quite familiar with them the more these sorts of questions you do. Just to note, though, there's no end to prime numbers, of course, because numbers can just keep going bigger and bigger. But there are mathematicians out there looking for the biggest prime numbers they can find, and as of January of 2016, the largest found prime number is over 22 million digits long. Now that doesn't mean it's over 22 million, the number. It means that the number has got 22 million digits in it. So you couldn't even write it down. It's absolutely massive. Only computers can handle it. And they're still looking for even bigger ones as well. So that's prime numbers for you, and that's mathematicians. They're all crazy. So let's have a look at some practice questions. Remember to pause the video. And there's our solutions for those ones with just a little bit of working that you'd need to show. So in the first one, we just had to see if 9 and 17 are prime or composite. So I started with 9 and I thought, does anything go into 9? Is there any other way to get 9? And there is. 3 times 3 gets 9. That means that it would be a composite number. And for 17, racked my brains, looked at my times tables, couldn't find anything, so concluded that only 1 times 17 gets 17. That makes it a prime. And with practice question 1b, I found all the factors of 20. First of all, and then I went through. 1's not a prime number, we discussed before. 20's got 2 times 10. 2 is a prime number, same one we saw before. 10's got 2 times 5. 4's got 2 times 2. And 5 only has 1 times 5, so that's the other prime number. And so I just wrote those two down. So if you need to have another go, here's another couple of practice questions. Remember to pause the video. And there's our solutions to those ones. And that brings us to the end of the lesson.